Welcome to Klimawissen Online again on our YouTube channel. Our today's speaker is Juliette Martin from the International Institute for Applied System Analysis. Juliette has been working at this institute since 2018. She has a multidisciplinary background in marine conservation and has studied at the University of Edinburgh. Before joining this institute for applied system analysis, Juliette worked at the UNEP World Conservation Monitoring Center in Cambridge. And there she led work on areas beyond national jurisdiction and marine habitats. And previously, she has worked on coral reef biodiversity in Japan and researched marine mammal bioacoustics. Yeah? And her topic today is marine ecosystems in climate change. And now, Juliette, as a welcome to you, thank you that you have time for us today. And I would say the stage is yours for the next minutes.
Okay, thanks so much. Right, let me share my. Now this should be.
Looks good.
Yeah, looks good.
Yes, great.
Okay, thanks so much. Okay, hi. So good morning, everyone. I'm very excited to be here, also about so many people joining and being interested about marine ecosystems under changing climates. So big thanks to Michael for organizing this and for his team as well. He's already introduced me, so already you know a bit about me. One thing that I did want to add is that I actually grew up in Vienna, but I always knew that I wanted to be a marine biologist. So when the time came to pick studies, that's when I decided to go to England to study marine conservation. So I've been very fortunate and I've been very lucky to work on different marine ecosystems. And now I'm mainly working on policy, marine policy and other policy. Okay. So these are the things that I would like to cover. So I'll start with a bit of background on what marine biodiversity really is. And then I'll move on to the kind of main part of the presentation on climate change and how it's affecting our oceans. And I will then talk a little bit about the other threats as well, because I think it's important to do so. And I'll finish on what we can kind of do, what the solutions are to some of these problems. Okay, so the first part is just a bit of background on marine biodiversity. And I thought it might be quite fun to actually hear from you what it means to you, basically. And there's no right or wrong answer. I just want to hear what everyone thinks of when you think of marine biodiversity. What's the kind of first word that comes to your mind if I say marine biodiversity? And I've been told that you're allowed to take out your smartphones for that. There should be a Menti link either now or soon in the chat for you to access. And
I have just put the Menti link into the chat. I hope that all of the teachers can see it in the link. Perhaps you can also write the link on the blackboard, so all of the students can see it. And please allow them to use their smartphones now. You can, if you are on a smartphone, just go on www.menti.com and then / and then you see it in the link. I said in German Y41GSMF7D5. I hope you can all see it you can all see the chat. Otherwise, just give me a notice in the chat if you can't see it. And I'm sure many of you know how to handle Menti.
Yes, I also assume that a lot of you will know Menti.
Yeah,
there are two ways. There's a direct link, or there's also just a general link that you can see on my slide with a code.
yeah. Yes, you can also go on menti.com and then use the code 67603844. Once again, menti.com and put in the code 67603844 or use the chat link. there are any technical problems or questions, just give me a note in the chat. The results are hidden now.
Yeah, I keep hiding and I'm finding them.
Yeah, they keep.
I have to say it's the first time that I use Menti within the slide. So if this doesn't work, I will just put the browser. I have the browser window open as well.
Okay. The people that just arrived now, we are just doing a Menti.
Okay. I'm figuring out what's happening because normally you would see some.
Yeah, Juliette, I just see that the question we have here on your screen, when you think of marine biodiversity, is another question than the link you sent me, because the link you sent me was the question, in your opinion, what is the biggest threat for marine biodiversity?
Aha. Normally it's the same link for both questions, but let me find out then. I think I just. This is the technical challenge if you want to interactive. If it doesn't work, it doesn't matter. We'll move on. But let me just try one more thing.
Yeah. Oh, one more moment. 3844. I'm just. In your opinion, what is the biggest? Interesting. Yeah. If we put if we use this code 6760, we come to the question. In your opinion, what is the biggest threat to marine biodiversity? So it links to another question.
Another question. Okay, then this might not work then. How about?
We can do it other words. In the classes, you could perhaps you can write the word that you think first into the chat.
Yeah, that's also good.
So just perhaps the teacher of you can type in the words that you tell your teacher in the chat, and perhaps we try it this way. When you think of marine biodiversity, what is the first word that comes to your mind? Just try to type in some in the chat. Okay, there's the first. Korallen is the first word we can find. Coral reef. Fish, coral reef. Fish, again, fish. Pollution, overfishing, coral reefs, plastic, fish species, Seegraswiesen. What else comes into your mind?
A lot of animals and habitats.
SpongeBob, sure. was also my first word. Large variety of fish. Plastic trash.
Yeah. Thanks. Okay, I think this already gives a good overview. So a lot of fish, of different threats, some habitats, some corals. Okay, yeah, sorry that this didn't work, but it means that the second Menti will work, hopefully, since it's the only one that does work from the two. Okay, so I think all of you are right. There is no wrong answer really, and the idea was to give you a bit of a snapshot of all the different things that marine biodiversity represents. So it's all of these things and many more. And really, what biodiversity is the diversity of life on Earth. So it's the diversity of different species, different flora, fauna, ecosystems, habitats. So you got all of these things completely right. And some of these are quite straightforward. And I know, for example, I think of turtles or, of animals. That's kind of the first thing that comes to my mind. But a lot of these things are also less visible things. So, for example, the air we breathe, or our climate, drinking water, storm protection, all of these things are also associated with marine biodiversity. And I wanted to briefly just draw your attention to some of these key marine ecosystems, since I'll be talking about some of them today in a bit more detail. So you have mangroves, which maybe many of you know. So they're a bit like the forests of the sea. They're trees that are tolerant to salt water, so they kind of grow between the sea and the land. You have seagrasses, which I know somebody mentioned when they thought of marine biodiversity, which are a bit the equivalent of meadows in the sea. You have salt marshes, which are kind of semi-inundated areas, again, between land and sea, so marshy areas or swampy areas. And of course, you have coral reefs, which I think a lot of you will know.
Juliette, just a question in chat. Someone writing, it's a bit quiet and hard to understand. Is there a way to have the microphone closer to you?
I think I can hold it. Is this better?
I think it's better, yeah.
Yeah, okay. Yeah, please do let me know if the sound is bad. I sometimes do have sound problems. Okay, I hope this is better. I'll just hold this now. Right, so I just wanted to basically mention some of these very important marine or coastal ecosystems. And what they all have in common is that they provide different hiding places for fish and other organisms, like shrimp, and they're also nursery grounds, so places where the young or the babies can be raised for fish and other organisms. They're places where animals find food. So in short, they're all very important for many different species and therefore for marine biodiversity. And on top of that, they also have other benefits. They provide protection from storms, for example, and from floods. And they also store a lot of carbon. So they're very important for regulating our climate. My aim here was just to, I hope it gives you a bit of an overview of the very wide-reaching benefits of marine biodiversity. Okay, and if you're still wondering why you should care, our oceans actually cover most of the Earth's surface. And for that reason, they are very important for human livelihoods, for human lives. Of course, in a country like Austria, where there is no sea, it might be hard to imagine that the sea has an influence on your everyday life. So you might think, what do I care? It's kind of far away. I'm not affected by it. But whether you live close to them or not, I can guarantee you that every one of you is depending on the sea for having basically a quality of life. First of all, one of the things that a lot of people don't know is that most of our heat is absorbed by the oceans. It's actually a huge number. So they have been absorbing over 90%, it's estimated, of our heat. So they regulate our climate. And without them, everything that's been going on with climate change so far would have been a lot worse. So they have kind of acted like a buffer for climate change so far. And they also store a lot of carbon. So the oceans, but also the coastal ecosystems. They're also very important for providing jobs, for providing food, for our water cycle, for oxygen. So it's estimated that nearly half of the world directly relies on the oceans for either job, for food, and for the other things they provide. So a lot of people depend on the oceans, and we do as well. But all of these things and all of these processes rely on the oceans being healthy. And climate change is weakening the ability of the ocean and the coasts to provide some of these things. So we're not doing so well. So what's the current situation? Marine ecosystems are, as I said, not doing so well. There is a rapid decline in a lot of ecosystems. They're under a lot of pressure. It's estimated that we as humans have altered 2/3 of the oceans. We have lost a lot of marine species and a lot of marine habitats over the last decades. So it's estimated that around a third of marine mammals are threatened. Fish have declined by 40% in just 40 or 50 years. And yeah, so that's kind of the trend. And my aim with today is to give you an overview on why that is, because to find a solution, we need to understand first what the problem is, right? Okay, and now, so this is working. So this is now the second Menti. If you haven't voted yet, please feel free to now, try the same link that Michael sent before. And the question here that I'm curious about is what you think, personally, again, no right or wrong question, what you think is the biggest danger to marine biodiversity? So maybe I'll give you, 30 seconds to a minute just to do it again, but I see a lot of people have already filled it out, but it's still changing. So this is what it was meant to do before. You're meant to kind of see the results live, which is nice. So far, I can see a lot of you have put down overfishing and plastic pollution as the main threats. Okay, it's not changing so much right now, so I think maybe most of you have voted, and in fact, it's a lot of people, isn't it? 130 people alone for these two. Okay, so basically the general trend is that overfishing and plastic pollution are seen as one of the most, or two of the most important threats. So as I said, there is no right or wrong answer, since different researchers will tell you different things, right? And also different habitats and different places of the earth and different species are affected differently by these threats. So it's not as simple as that, but the general consensus is that in terms of the different threats, overfishing is one of the most important ones. So here it's called direct exploitation, but it's the same thing as overfishing. And climate change, you can see, is actually not the highest, or it is high, but it's not the highest, because habitat destruction and changes to habitats are the biggest, or considered the biggest threat, at least to species that are threatened. So again, there's some debate on this. What I think is interesting, and I expected this, I have noticed in the last years, since I started, working in this field, that marine plastics is perceived as one of the biggest threats, and it definitely is a very big threat, but it is not the biggest. And I think, my interpretation is that there's been a lot of media coverage of that, but we tend to forget sometimes that there are other things going on, like overfishing, for example, or habitat destruction or climate change, that might be just as important, if not more important. So it confirmed what I thought, that a lot of people think that plastic pollution is one of the biggest threats, and it's because it's been discussed a lot, right? So I just wanted to put this here to put this into perspective before I start. Okay, moving on to the bulk of the talk, which is climate change and how it's affecting our oceans. So the first thing I wanted to talk about is ocean acidification. I don't know if many of you have heard about that. Basically, what is happening is, as I mentioned before, our oceans are very important for regulating our climate, and they absorb a lot of the atmospheric CO2. So they've actually absorbed a third of all atmospheric CO2. And when they absorb CO2, the CO2 then reacts with seawater to produce hydrogen ions. And maybe you know that hydrogen ions are associated with acidity. So the acidity goes up, and as such, that's not really a problem, because that's a normal process and it's always been happening. But since CO2 levels are now going up so much, more CO2 is being absorbed and more hydrogen ions are produced. And as a result, we do really see that the ocean's pH is going down. And you might still think, okay, so what? Okay, it's a bit more acidic. But the real problem here is that there's another chemical reaction that then happens afterwards, and which uses up carbonate ions. And carbonate ions are what different organisms in the sea that have a hard shell. So all, the snails, the corals, the mollusks, the oysters, all the organisms that have a shell use these carbonate ions to make their shell. So now that there are less of these carbonate ions, it's becoming a lot harder for these organisms to produce their shells. And there are also other organisms that use carbonate ions. They are called plankton. So these are tiny organisms that build shells. And you can see on the right, for example, it's these guys. They look a little bit like aliens. And they're made of calcium carbonate. So they use these ions to produce their shells, and they form the base of the food web. And on the left, you can see, very simply put, what the food web looks like. And you have these plankton here, which form the basis of everything. So, of course, if that changes, if the plankton is either reduced in size or in quantity, that means that the predators that feed on them, or the animals that feed on them, are in trouble. So the entire system has a problem, and it can have very wide-reaching effects. And we are already observing that plankton shells in many parts of the world are becoming smaller and are becoming more deformed. Moving on to another phenomenon, which I think many of you will know, it's called coral bleaching. And if you look at the picture on the right, you see this white coral, which at first, reaction is very beautiful, right? So it's my first reaction, if I didn't know what it means, is that's nice, that looks really nice. But something is actually wrong because corals are meant to be colorful. And the white coral that you see on the right is a bleached coral that is most likely going to die. So why is this happening? Why are they turning white? Corals are, as I said, usually quite colorful. If you've had the chance to see them in real life, that's what kind of makes them so beautiful. And the reason they have these colors is because they have a microscopic algae that lives within them. And they have this kind of friendly cooperation between the algae and the coral. The algae have a horrible name. They're called Zooxanthellae. And basically they feed the coral, and the coral in turn protects the Zooxanthellae. So it's kind of this, win-win situation. It works out for both of them. But the problem is that this algae is very sensitive to temperature changes. So when the sea temperature is rising, as is now the case with climate change, the Zooxanthellae leave the coral, and the coral eventually dies. So even if the temperature then returns to normal, the Zooxanthellae, they don't return. So we're now seeing these mass bleaching events that are happening more and more. And yeah, so it's just very worrying. And it makes corals one of the most vulnerable ecosystems to climate change. Then you all know that sea levels are also rising. Global warming has led to the shrinking of the world's ice cover. So that's the ice sheets, the glaciers, the snow cover. So more fresh water is going into the sea. But it's not actually the main reason for the sea levels rising. That's due to something that's called thermal expansion. It's a physical phenomenon that basically just says, if I simplify, that things take up more space as they warm. And for this reason, the sea has risen by 3.6 centimeters on average, over the last 10 years. So you might think, in total, right? So it's 3.6 millimeters per year. And that's tiny, right? That's really small. And you could think, okay, that's probably not going to make a big difference, right? But the problem is that even 3 millimeters actually make a big difference for a lot of the marine ecosystems that I mentioned. Coral reefs are among them, salt marshes that I mentioned as well. It has a big impact on the coastlines. And of course, it also has a big impact on people. Most cities, or a lot of cities, are built very close to the sea. Everyone loves the beach and the sea, and more people are moving to the coastline, especially as temperatures are getting hotter. But a lot of these zones are actually low-lying or even below sea level. So they're exposed to changes in the sea levels. And even very small changes over time have a big impact, especially on storm surges. So that's when you have a storm and the water level goes up a little bit temporarily, and then, of course, floods. So it's the combined effect of the two. And you can think of it like taking a bath. So if you have a bathtub and it's quite full and you jump around in the bath, it's more likely, if the tub is very full, that the water spills over. So the sea is a little bit like a very big bathtub, and the storms are like, somebody moving around in the bathtub. And even if you don't move around so much, so even if you have small storms, if the water level is higher, you still have a higher chance of water spilling over. So even small storms have big consequences, and we know that storms are likely to increase with climate change. Another issue with this is glacial melt. It's especially catastrophic for polar animals. I know everyone loves polar bears, I know I do, but they rely on snow to be very compact, to be able to build their dens for their cubs, but also to find food. So they need to be able to walk around between ice sheets to find food. And as the ice becomes thinner, they can no longer go from one place to another, and they can starve. And the same is true for people. There are a lot of local communities living in polar regions, and they also rely on the ice basically to survive, right, to live a life. Again, here, the issue is the rate at which all of this is happening. It's too fast for ecosystems to adapt fast enough. And the next issue that I wanted to mention in relation to climate change in the oceans is our changing currents and temperatures. So you might all be too young to know this movie. I saw it when I was a teenager, and I realize now that, shockingly, a lot of you were probably not born. But if you know it and you want to look at a catastrophe movie that is so bad that it's good, I recommend it. But it's the reason I'm mentioning it is because it's actually funny that it's based on some scientific concepts. So the idea is that due to climate change, the Gulf Stream, which is a very important current in the sea, stops, and then this has a catastrophic effect on the USA. Everything freezes over. There are tsunamis, you name it. But what's interesting is that there is some truth in it, although it's very dramatic and very exaggerated. It wouldn't happen this fast. But the idea that if a current shuts down, if a current changes or slows, it can have very wide-reaching effects on our climate. So there is some truth in it. And if I simplify the way marine currents work, basically you have cold, dense water that moves at the, that sinks and that moves at the bottom of the sea, and then the warm, less dense water rises to the surface, and that then creates this current, a bit like air, basically. And what we're observing now is that ocean currents are actually slowing down in different parts of the world or changing. And it is most likely due to climate change, of course, and also to chemistry changes in the water, because more fresh water is entering the sea because of glacial melt. And that can have a big impact on our weather system long term. And that's just one side of the coin. The other side of the coin is that it's also a big problem for a lot of marine species, especially mammals, because a lot of them migrate in function of where there's food. So, they will travel thousands of kilometers, especially marine mammals, in function of where their food is situated. And where the prey is situated depends on currents. And if currents change, it can have very big effects on marine ecosystems, because the species will not find the food that they would usually find in a certain place. And that's just the spatial aspect, but there's also a temporal aspect, and the seasonality is very important. Think of it as every species has a very precise appointment with another species on where they meet at what time of the year. And right now, as everything is changing, the temperatures are changing and the currents are changing, they just keep on missing each other, basically. And we are already observing that this is happening. For example, on the right, you can see here with the black sea bass and the Atlantic cod, they are going to deeper waters and colder waters because they're trying to find, these conditions that they like of cold water. And since everything is becoming warmer, they have to go elsewhere. So it's becoming, a bit of a mess. And a final thing that I wanted to mention in association with changing temperatures of the sea is that this is a relatively new phenomenon. It wasn't talked about so much when I was studying, but you have now what is called marine or ocean heat waves, which are extreme warm weather events that last at least 5 days in a row. And they're becoming more frequent, they're becoming longer, and they cover more areas now. So the consequences are, as I just said, different species will then shift, where they are, shift their range. But also warm waters strengthen tropical storms and hurricanes, because that's what hurricanes need to be formed. So they're also likely to increase because of that. And of course, we saw already corals or other sensitive ecosystems are also affected by temperature changes. There have been mass mortality events in seabirds or invertebrates because of these ocean heat waves. So it really does have a very big impact. Okay, moving on. I am having an eye on the time. So since the main topic for today's lecture was climate change, I have focused on that, but I couldn't talk about marine biodiversity without at least mentioning some of the other threats, because they're just as important, but also it's not just that, it's the fact that often things are looked at in isolation, and the different threats that I mentioned, there's also a combined effect of climate change plus other threats. So you can't really look at it in isolation. You need to take the whole system into account. Since I don't have time to go into detail about all of these, there's just two that I'll cover, which are the most important ones from the beginning of the lecture. So overfishing and land use change. I will just briefly mention what the main issue is with those. In terms of overfishing, our demand for fish has just risen so much. So we eat twice as much more fish than 50 years ago, and the demand keeps rising. And the main issue is that basically our capacity to fish is a lot larger than what the ocean can supply. So most fisheries are currently either fully fished or overfished, and we're not letting fisheries the time to recover. Because, as I said, our technical capacity, so the fishing fleets, what they can do is just so high that the fish don't stand a chance, basically. There's also the issue of bycatch. At the times, sharks or dolphins or small whales will also end up in the nets because the nets can't basically differentiate between fish and bigger animals. So that's also, a kind of a side note to that, but fisheries science is very complex, and it's very complex to calculate how much you can fish sustainably. But what we do know for sure is that we're fishing too much right now, and many fisheries of the world have already collapsed, and some will never recover, and more will follow if we don't change the way that we fish right now. In terms of habitat loss and change, the sad part is that we have already lost a lot of habitats. I know that terrestrial deforestation, of the Amazons, of other places, are very much, people are very aware of that. But the fact that mangroves, for example, are lost at up to 5 times more rapidly than terrestrial forests, it's a bit more invisible, right? People are not necessarily aware of that. And there are many reasons for habitat loss and change. Mainly, it's coastal development. So, of course, we are building very close to the sea. We had to make space for humans, for ports, for buildings, and a lot of ecosystems, had to be basically drained or destroyed or converted to make space for humans. But also, a lot of non-coastal areas are being damaged or lost. Fishing does have a big impact. An example here is this type of fishing, so it's called bottom trawling. And with bottom trawling, basically the net is dragged across the seafloor, so it just scrapes everything off like a bulldozer, and destroys everything on its path. So, things are changing, and people are becoming aware of these fishing methods that are very damaging. But there's still a long way to go. And of course, a lot of habitats are lost due to climate change. Pollution is a big one. Plastic pollution, of course, but other pollution as well. Land-based pollution is a big problem. Also sea-based pollution, oil being spilled. So habitats are being destroyed by many different things. There's tourism as well. There's illegal fishing practices. And it's actually one of the most diverse causes of biodiversity loss because it covers there are so many different reasons behind it, and all of them interact with each other. I just wanted to say that there are a lot of things we don't know. There are a lot of marine species that we haven't discovered yet because the oceans are still hard to reach, or a lot of them are still hard to reach. And all I wanted to say here is that, bear that in mind. There are, of course, predictions. We don't have a crystal ball, but we can see the direction in which things are going. And it can always go in one way or the other in terms of predictions. But so far in my lifetime, or since I entered the marine field, most things have been more on the worse end than what was predicted. So things actually turned out worse than what was predicted. But there are still a lot of unknowns. Okay, I see I'm a little bit over time. I hope that's okay, Michael. I'm now at the last part of the presentation, and I know that's all a little bit depressing, and it can be, you can feel a bit helpless, and I know that I have felt helpless in the past. And so I wanted to show that there are solutions, and there is some hope, and none of these solutions are miracle solutions. They can't fix all the problems at once, but realistically, combination of these can help. So of course, the obvious solution is protecting more of our seas. Currently, marine protected areas cover not even 8% of the entire sea. And many scientists argue that that should be a lot closer to 30% to really have an impact. But also the issue is that out of these 8%, not all of these marine protected areas are actually protected. So they can be protected on paper, but in reality, activities are still not controlled or regulated in them. So that's also an issue. And then I mentioned briefly before, I worked a lot on the high seas. So that's everything that's not within national waters, so further from the coast. And that includes the deep sea. And the high seas are currently very underrepresented. Only about 1% is protected. There are discussions at the UN level to change that, but we still have a long way to go. There's also something called nature-based solutions, which has become also one of the topics that I'm researching on a lot. And these are solutions that are inspired by nature or using nature's properties. For example, if you have a risk of coastal flood, the first approach would be to just construct a seawall, right? That's kind of the traditional approach, to put some concrete there. But an alternative would be to plant mangroves, for example, because as I said, they are very good at diffusing energy from storms and from waves. Or same with dunes in Europe, that's maybe more of a better example. So it's a bit of a win-win situation because they provide a lot of benefits, but they're also more natural solutions. Yeah, so that's all I wanted to say about that. Of course, there are other, promising ways forward. I don't have time to mention all of these in detail, but I think the reason I'm here today is that I believe that there's a lot to do in terms of marine education. I hope that the future generations can understand the issues that we're facing better so that we can start moving into the right direction and stop doing things that we've, been doing the same way. So stop doing the same things. Of course, it's very hard for us to understand here, sitting in Europe, that a lot of people of the world depend on the oceans to survive, just to survive. And whatever happens, these communities need to be part of the solution. They need to be protected. They're the most vulnerable to all of these changes. There are sustainable fishing practices, not many, but there are now things that are being developed in terms of aquaculture and introducing different species there so that it's not just monocultures. There are eco-labels. I'm sure you've heard of the MSC, the Marine Stewardship Council. So there are ways to, eat fish more sustainably, but also maybe eating less fish would also be a solution. And of course, the big elephant in the room, which I know every one of you is aware of, is we just need to reduce our emissions. We just need to curb this curve. And you could protect the whole sea tomorrow, right? You could put a marine protected area over the entire sea. But if we don't change our greenhouse gas emissions, the climate is going to continue to change and it won't help. So it won't save anyone. So if I summarize, and sorry for being a bit over time, there are a few things I wanted you to get out of this talk, mainly for you to understand what the different threats are to the marine environment. Many I didn't have time to cover, but feel free to use the Q&A if you want me to tell you a bit more about something else. And I hope that what you got out of this talk as well is that everything is connected. So it's a very complex system, and if one element fails, everything else is impacted by that. There is, of course, climate change adaptation. Some ecosystems can adapt. Nature is resilient, but there are limits to that, and the rate at which we're changing the marine systems right now is just too fast for a lot of ecosystems to adapt. But everything is interconnected, and the fact that there are many threats on the oceans, that's a problem because they interact between each other, and it becomes then, climate change is just a cherry on top of the cake. It's just an extra problem on top of everything else. And there's, of course, a lot we don't know, but we do know that things are getting worse and not better. It's not all doom and gloom, so don't feel like you need to despair. There are solutions. I know a lot of them are easier said than done. It's not easy to change things. But for me, at least, the oceans have always been a very big source of magic, of fascination, of happiness. And I believe they're worth fighting for. And even if just a few of you feel the same way, then I think there is hope, you know, to turn this around and to preserve these habitats before it's too late. So on that note, I wanted to say a big thank you for listening and also apologize for going over time. And I look forward to your questions.